Hello and welcome to Cashmatics. This is the second lesson in my series on vectors. In this video, I'll show you how to identify parallel and perpendicular vectors as well as calculating the magnitude of a vector. It's going to be a nice short video, but there are some important details which you need to make careful note of. So grab yourselves a pen and some paper and let's crack on with it. So the first thing we're going to look at is parallel vectors. Okay, and hopefully you can see that I've got 5 vectors on the board which are parallel. Okay, and one of them isn't. And what we're going to do is we're going to look to see what the properties of parallel vectors are in terms of the numbers. So let's go ahead and write down the values of these vectors and see what we can observe. So remember, the vectors, you go across first and then up and down. So vector A is 3 to the right and 2 up. So that would be 3, 2. Vector B is 3 to the left and 2 down. So that's minus 3, minus 2. Vector C is 6 to the right and 4 up. So that'd be 6, 4. Vector D is 9 to the left, so minus 9 and 6 down. That's minus 6. And vector E is 4.5 to the right and 3 up. So 4.5 and 3. And what we're going to do is we're going to see how these vectors at the bottom here are linked to vector A. And if you haven't already spotted it, you'll see they're all multiples of vector A. Okay, so vector B, for instance, okay, it's almost the same, it's just going the other way. So it's minus 1 times by vector A. Okay, so it's still a multiple, it's just a minus 1 is the factor. Okay, vector C is an easy one to spot, is actually double vector A. Vector D is minus 3 times vector A, so it's going to be minus 3A. And vector E is 1.5 times vector A, so vector E is 1.5 times vector A. Now you might be wondering why I bothered drawing vector F on the board. Okay, so let's just have a look at the size of vector F. Okay, so vector F goes 9 to the left and 6 up, so minus 9, 6. And the reason why I put that there is because 9 and 6 are 3 times 3 and 2. But what you need to make careful note of is this negative sign here. Okay, it's not quite 3 times that vector, and it's not minus 3 times that vector either, because 3 times that vector would be 9, 6. Okay, and that isn't 9, 6. And minus 3 times that vector would be minus 9, minus 6, which this isn't either. All right. So if you're not careful, what you might do is think a vector is parallel to another when it actually isn't. Okay, so please make sure you take careful note of that. So let's summarize what we've got. So if 2 vectors are parallel, one will be a multiple of the other. So what I've got here is a question for you to try. Vector A is 5 minus 4, and what I want you to do is work out which of those 6 vectors is parallel to 5 minus 4. Okay, and as always, pause the video and I'll go through the answers in a little while. So hopefully you've had enough time to do those questions. Let's look at this first one here. The first one is nice and straightforward. Okay, 2 times 5 is 10 and 2 times minus 4 is minus 8. Okay, so that one works. Okay, so that one's equal to 2a. This next one here, 5 times 4 is 20, but minus 4 times 4 would be minus 16, not 16. So this one is not parallel. Let's have a look at this next one. 5 times minus 3 is minus 15, and minus 4 times minus 3 does make 12. Okay, so that's fine. So that's minus 3a. This one here, 5 times minus 3 is minus 15, but minus 4 times minus 3 would be 12. Okay, so that one isn't parallel. The next one, 5 times minus 1.5 is minus 7.5, but minus 4 times minus 1.5 for a start would give us a positive number. Okay, it gives a positive 6, and this is a negative 6, so that's not correct either. And the last one, 5 times minus 2.5 is minus 12.5, and minus 4 times minus 2.5 would be 10. Okay, so that's correct. Okay, so that's minus 2.5a. Okay, so ask yourself how you got on with those. If you made some silly mistakes, go back and try to iron out those issues, and let's move on. So the next thing we're going to look at is perpendicular vectors. So let's just have a look at the vector A. So A is 4, 3. Okay, and hopefully you can see that vectors B and C are perpendicular to vector A, which means at right angles to it. And although they're going in opposite directions to each other, they are at right angles to vector A. So let's just have a look at vector B. Okay, and vector B is 3 minus 4. And vector C is minus 3, 4. Okay, and these two vectors here are very similar to each other and very similar to this one here. Okay, so hopefully you can see that the numbers have been flipped over. But not only that, there's a bit of a change with the signs as well. And what's actually happened is this. When you're writing a perpendicular vector, the first thing you do is you flip the vector over. And then what you do is you change the signs of one of those numbers. Okay, so one of these components you change the sign of. Only one of them, not both of them. So I can choose to make that negative, or okay, so this was the state it was in. I could choose to make that one negative. Okay, and both of those will give me a perpendicular vector. Now, if you look at vectors D and E, okay, vector D is 6 minus 8, and vector E is minus 6, 8. Okay, and both of these two are actually multiples of these vectors. Okay, so these two, D and E, are parallel to B and C. Okay, but they're slightly longer. All right, but they're still parallel to B and C, which means they are still perpendicular to A. So the easiest way to make a perpendicular vector is, first of all, flip the vector over, change the signs of one of the components, and then multiply it up if you want to, but you don't have to. Okay, if you want to recognize whether a vector is perpendicular and it is longer than the original, then you'll have to see if the perpendicular vector is a multiple of the basic perpendicular vector. All right, so let me just do another example. So imagine I had something like 2 minus 3. Okay, so that's the original vector. If I want to write two perpendicular vectors, the first thing I do is just flip the vector over. Okay, so I'm going to flip the vector over. And what I'm going to do is change the sign of one of the components. So this minus 3, I could change into a positive 3 by doing that. Or what I could do is I could choose to make the 2 a minus 2. All right, so both of these vectors will be perpendicular to 2 minus 3. And if I want to make another perpendicular vector, what I could do is I could just multiply this one up. Okay, so I can pick any number I like, so something like 7. 3 times 7 is 21, 2 times 7 is 14. Or I could do the same with this one. Let's just pick 9, for instance. Okay, so minus 3 times 9 is minus 27, and minus 2 times 9 is minus 18. Okay, let's just do one more. Okay, let's just do one more. So let's say I had minus 4 minus 7, for instance. Okay, let's just write down two vectors. So minus 7 minus 4, minus 7 minus 4. I just need to change the signs of one of them. Okay, so I could make that one positive, or I could make that positive, and I've got two perpendicular vectors. Now, if you're unsure, what you could do is you could just sketch it. So imagine I had a vector 1, 2. Okay, now ignore my square grid. 1, 2 would be something like that. Okay, 1, 2, and a perpendicular vector would go this way. Okay, so if you look at the diagram, minus 2, 1, if I'm going from here to here, or 2 minus 1 if I'm going from there to there. So if you're unsure when it comes to an exam, just make a sketch and then hopefully you'll get it right. So just to summarize, for a perpendicular vector, flip the vector and change the signs of just one of the numbers. So I've got some here for you to try. What I want you to do is write down the two basic perpendicular vectors. Okay, so flip the numbers and change the sign of just one of those numbers. Okay, so pause the video and I'll put up the answers in a little while. So I'm about to reveal the answers in 3, 2, 1. There you go. Okay, so hopefully you've got those right. Now the last two I'd say are the trickiest out of them lot. Okay, so the first four, so when I say the first four, I mean this one, this one, this one, and this one. Those were just following the rules like I showed you, but these last two are a little bit tricky, and I'll show you why why they are. Okay, so the whole flipping the thing over and changing the signs, it kind of works, but it might not be so obvious as to why it's happening. Okay, so if I was to flip this one over, it becomes 7, 0. Okay, but if I change the sign of the 0, it just stays as 0. So that's what's happened here. And if I change the sign of the 7, I get minus 7, 0. Okay, and a similar thing has happened over here. But like I said, you can always sketch if you're unsure. Okay, so 0, 7 just goes up 7 units. So a perpendicular vector will go 7 units that way or minus 7 units that way. Okay, so it'll be 7, 0 or minus 7, 0. So hopefully you can see what's gone on there. And something very similar happens over here as well. The last thing we're going to look at is the magnitude of a vector. And in this case, the magnitude of a vector means the length of the vector. Okay, so if I look at this vector A, it's the length of this yellow line here. Okay, and from this diagram, hopefully you can see that you can use Pythagoras to work that out. So how far across I've gone, that's the x component of the vector. How far up I've gone, or how far down I've gone, that's the y component of the vector. And these are like the lengths of a triangle. So this length here squared is equal to x squared plus y squared. So therefore, so let's just write that down. A squared is equal to x squared plus y squared. So this is, imagine A is this length here. Then A would be the square root of x squared plus y squared. Okay, and I've got that summarized over here at the top. So let's just look at some notation we can use first. The magnitude of vector A is written as the vector A with 2 vertical lines either side of it. And if vector A is xy, then the magnitude of vector A is the square root of x squared plus y squared. So let's say I've got a vector B, and it's 4, 3. If I wanted to work out the magnitude of B, it would be the square root of 4 squared plus 3 squared, which would be the square root of 16 plus 9, which is the square root of 25, which is 5. Okay, so the square root of 25 is exactly 5. If I had another vector, so let's say vector C, and that was minus 5, 4. If I wanted to work out the magnitude of that vector, I could just ignore that minus 5, because whether or not something goes that way, or that way, as long as they're the same length, it doesn't change by which direction they've gone in. Okay, so what I can do is I can ignore that minus 5. And the reason I say that is because quite often what people do is they'll write minus 5 squared, but then think it's minus 25, and it's not. Remember, whenever you square a number, the answer is always positive. So this here becomes the square root of 25 plus 16, which is the square root of 41. And because 41 isn't a square number, I'm going to leave that answer as the square root of 41. Okay, and that's perfectly acceptable. Unless the question asks you to write it to a few decimal places, then obviously do that. But in a non-calculator paper, that would be perfectly fine. And if it was a surd you could simplify, then you can go and simplify the surd. So here's some questions for you to try, and pause the video and see how you get on. So I'm about to reveal the answers in 3, 2, 1, and there they are. Okay, so hopefully you got this right. There's not really a lot to it, and you just need to watch your signs and make sure you don't make those silly mistakes where you start subtracting when you shouldn't be. And that's it for now. So hopefully you know how to work out whether two vectors are parallel, whether two vectors are perpendicular, and how to work out the magnitude of a vector. If you were rusty with your surds, or you don't know what a surd is, I've got a whole video on surds which should teach you everything you need to know about surds for GCSE. And in the next video, what I'll be doing is covering some vector geometry, and that together with the first 2 videos should give you everything you need to know about vectors for GCSE. Thank you for watching, and I'll see you next time. Goodbye for now.